Hey guys, this is Mr. Mead and I'm going to start talking about surface area and volume of prisms and cylinders. So in order to do that, we're going to go through a PowerPoint. We're also going to manipulate some actual real life shapes and just kind of go through some of these and show you why things actually work.
In order to study three-dimensional solids, we probably want to make sure we know the vocabulary, so I've put it on the screen. When we say a solid, we're talking about any three-dimensional shape. The face of a solid is the two-dimensional side of a solid. So if I have, for example, a triangular prism, so a three-dimensional shape that looks like this, uh, any of these would be a face. So this triangle, that'd be a face. This rectangle on the side, that would be a face. The triangle in the back, that would be a face. So this particular shape that we are looking at has 5 faces. A base is any face of a solid that will dictate its name. And I know that's a really vague definition, but we're going to spend a lot more time on this later in the video. Surface area is the sum of all the areas of the faces. So we would take the area of the triangle plus the area of the other triangle plus the area of the 3 rectangles. So the one on the right side, the one on the left side, and the one on the bottom. We'd add all those areas together, and that would be called the surface area. Lateral area is the sum of all the areas except the bases. So whenever we figure out whatever the bases are, we would not include those in lateral area. And then volume will be a different video, but that's the amount of three-dimensional space that's enclosed by a solid. So when you think of pouring water into a cup, the amount of water that can fill the cup would be the volume. Now, surface area of prisms and cylinders is the focus of this. I'm just reminding us that the surface area of a three-dimensional solid is the sum, or adding up all the areas of all the surfaces or all of the faces that we have. So in order to do that, because we're going to spend some time with the formula later, we need to know what a base of a figure is. And today we're talking about figures with 2 bases. So prisms and cylinders all have 2 bases. So when we're talking about shapes, we're going to only talk about easy shapes. So shapes where it's very clear what's happening and it's going to make calculations easy. So as you see over on the left side of the screen, the barbecue sauce container, uh, while it may be possible to calculate the area of this, there is no shape in this container where if you put some side on the ground, every horizontal slice would result in exactly the same shape just because of the way that it's shaped. Therefore, we're not going to talk about containers like that. Um, we will talk about cylinders. So we'll talk about cylinders. They have a circle as the base. So when you're looking at the cylinder, the circle is the base, because if you put the circle on the bottom or on the ground and you made a bunch of horizontal slices, you would get circles all the way up to the top. Now, rectangular prisms are pretty easy. If you take, for example, a Jello box and you pick any side of the Jello box and you cut horizontal slices, so you put any side on the ground and you cut horizontal slices, you would end up with the same shape going all the way across no matter where you cut it. I'm showing you by cutting this cardboard box that if you cut the cardboard box, you end up with these rectangles that end up being the same size no matter where you cut the rectangle. So I just cut it in 2 different spots. I cut the rectangular prism and I ended up with this rectangle showing up all the way across. Now, on a triangular prism, that's a little bit different. So when you look at the video of this triangular prism, I have to make the triangle the base. If I try and make one of the rectangles the base and then I cut horizontally there, if I cut across, I'm going to end up with different sized shapes and different, like even different shapes. Like they look trapezoidal or something like that, and they're not actually what any of the shapes in the figure are. So that can't be the base. I have to pick the triangle, and if I pick the triangle, then I end up, when I cut this triangular prism all the way across, I end up with triangles all the way if I cut them in horizontal cuts if I put that triangle on the ground. Also, you'll notice that the lateral sides of prisms are always parallelograms, and in our problems, they're usually rectangles because we try and make the problems relatively easy for you. So let's take a look at this triangular prism. I just want to make sure that we understand that if I took the triangle and I sliced anywhere along here, I would end up getting a triangle all the way across. So if I put this triangle on the ground and made horizontal slices, I would end up getting a triangle anywhere I sliced. So that's why the triangle is going to be the base of this figure. Now, if we're looking at the area of this, the area of this is going to be 2 triangles plus 3 rectangles. So what I would do is I would find the area of each of these things, and then I'd add them all up, and then I could get the area of this shape, this triangular prism. Uh, Sometimes it's easier to do that, but if you notice, if I take a look at this triangle and I look at the perimeter of the perimeter of the triangle is also, if I combine these back together, the perimeter of the triangle ends up being the um, these 3 sides. 1, 2, 3. So the perimeter of the triangle ends up being that. And then if you notice, all 3 of these rectangles have the exact same side length for these squiggly lines. So that's going to come into play later when I calculate the area of that. If I'm looking at a rectangular prism, I actually, like I said, I have some options. So I could cut this way, and all of these would be the same rectangle. I could cut this way, and all of these would be the same rectangle. Or I could cut this way, and all of these would be the same rectangle, and it doesn't matter where I made the slice. So it doesn't matter which of the 3 I choose. But if I'm finding the surface area, I can make whichever one I want the base, and I would have to find the area of 6 rectangles basically and add it up. In a cylinder has a circle as a base. What ends up happening is, as you will see in the bottom of the screen, we have a rectangle that's actually what happens when you unwrap the perimeter, like this lateral area. Even though it's curvy right now, when you unwrap it, it actually ends up being a rectangle. And so what we have is we have 2 circles plus a rectangle. And if I look, I have to make the circle the base, because if I go this way, cut it anywhere along, I'll end up with a circle. But if I try to cut it the other way, like this, I would end up with a little archy thing and then a big archy thing, and I would end up with like some kind of rectangle in the middle. And those rectangles don't really match up with any shapes that we see in the figure. So I can't cut it like this. I would have to cut it using one of the circles. So the circle has to be the base.